and we're good to go.
Okay, excellent. Well, welcome everybody. Thank you for coming. Good morning, good afternoon, wherever you are in the world. I'm pleased to see that we've got people from many continents of the world. So we've got South America and North America and Europe, Africa, and I think there may be some people from Asia coming as well. So that's fantastic. So today what I'd like to do is tell you a bit of a story, if you like, about how zero leak rotary shear valves have helped a particular company. In this case, it's Mining and Oilfield Services. I'll add that this is an entirely fictitious company, but let's say it has a lot of parallels with many of the customers that we know and have met and helped over the years. And this particular company has two particular focuses, one on oil well safety equipment and the other one on mobile drilling rigs. And their mission as a company is to always provide a safe working environment, be a reliable supplier of choice, and provide innovative solutions. And so what I'd like to do today over the next sort of 30-40 minutes is just tell you a bit about their story, some of the people involved in the maintenance and design of their circuits, and some of the challenges that they've had, and some of the solutions that they've found in the process. So we'll start by expanding a bit more about this company. So it's led by a gentleman called Lauren, who's the CEO of Mining and Oilfield Services, been in the game a long time, understands a lot about the challenges of running a business, particularly a business with undoubtedly an aging fleet of machinery, where it's not always easy to make a profit, but you have to live by the mission that they have. And working for him, he has two people, Declan, who's the design engineer, who's designing updated safety equipment, and Steve, who's the service manager, whose job is to keep the winches on the mobile rigs going despite their age. And so what we're going to do today is just explore a bit more about the two challenges that Declan and Steve have and how they've helped Lauren succeed with his objectives for the company. So as I say, he's got an aging fleet of machinery. Fundamentally, that's starting to cause reliability issues, which is absolutely unacceptable for the customers that they serve. And often they're finding it's more and more difficult to get the spare parts that they need to keep the machines running. And clearly, when you're trying to keep costs down, that's also a big challenge. And so Declan's question is, how can I simplify the circuit and make the system safer? And Steve's challenge is, how can I keep machines running longer and keep the costs under control? And so this is a bit about their two stories, really. Where do we fit in? So Webtec, we've just celebrated our 60th anniversary last year. We were founded in 1964. We're based in the UK, team of about 60 people, with an American branch as well and a German branch to offer worldwide service and support. We're specialists in hydraulic measurement and control, and you may know us for sort of blue box testers and other measurement equipment, but we also have a long heritage in designing and manufacturing control valves, and that's where the zero leak rotary shear valves fit in. And the applications that these are used in vary enormously, and you can see some pictures on the screen of the different applications where these valves are found and provide that ideal zero leak function for generally high pressure, low flow applications. So we go around them. There's safety systems, marine deck equipment, portable tools, winches that we'll touch on today, test stands, sort of jacks and filter presses, pilot valves to control other valves, and cranes. So how do we help? How can we help Declan and Steve? So our approach as a company is we have a four-step approach to doing that. And our four-step approach we call Make It Blue. And what does Make It Blue mean? We look at the letters of blue, B-L-U-E, and they're an acronym, if you like, for beginning by really sharing information like we are today, technical information about how things work, and publishing information such as the book that we have there is a practical hydraulic system maintenance book, which we co-authored with Steve Skinner, who I think is on the call today, and is available via Amazon, but really just general background information on system maintenance and hydraulics. Particularly as we're aware, very many people are getting older in this industry and retiring, and we need to keep the information flowing to younger people joining the industry. And so that's the first stage, if you like, of our overall approach. The second is much as we're doing here with Declan and Steve, as we're listening to their challenges and going, how can we help? And then as a design, engineering, manufacturing company, we're looking to upgrade whatever solution we can to meet their requirements, and then engineer what we call a functionally superior product, and then afterwards to offer lifetime support. So that's a bit about us. How's that applied really in real life? Well, let's go back to the story of Declan and Steve and the challenges they've faced. So the first one, Declan, his challenge: how can I simplify the circuit and make the system safer? And he's managed to condense, if you like, his challenges in designing this simplified circuit into four key things. And the first one we're going to pick up on is how can he simplify the circuit so that where he might have used two valves, he can just get away with having one valve. And he wants that leak-proof directional capability. And why is that important? Well, clearly he's got Lauren breathing down his neck going, don't overspend. Try and watch the pennies, but equally make sure this is a safe, reliable and innovative solution. So what we're talking about is a classic sort of three position, 4-port directional control valve, as you can see pictured on the right, but it can't, in that center position when all ports are closed, you can't have any leakage. And on the left of that circuit diagram, you can see a section through a zero leak valve, and we'll talk a bit more about that in a moment. But let's just talk generally about directional control valves. And apologies if this is quite obvious to many people on the call, but let's just cover the ground quickly. So there's a section through a very classic directional spool valve, and we can see the circuit diagram at the top that it's a 3-position, 4-port closed center valve, and we can see the valve pictured underneath, and the fact that we've got the 4 ports there, A, P, B and T. So if we move the handle on the valve, we can see that we've connected A and P and B and T. And if we move the handle back and then in the other direction, we can see we've joined A and T and P and B. All very simple so far. However, if we were to sort of focus in on exactly what's happening there, we've got a spool moving inside a honed body, but there is inevitably a small gap there. There's a gap of about 5 to 10 microns between the spool and the edge of the body. Happens is you get a small amount of leakage through there. Typically, that's about 0.5 to 1 litre per minute at the rated pressure for the valve. In many circumstances, in many applications, that's not particularly critical, and that's why spool valves are widely used in lots of hydraulic applications. But where that application requires that you have zero leak, 1 litre is a lot of flow. What it also means is that flow will bring with it small particulate, and that particulate may just flow through, but equally it may get stuck. And when it gets stuck, you can get a build-up of particulate, and for applications where the valve may only be used occasionally, often in a safety system where the handle may not be moved every day or every week, it may be months between the time it's used first and the second time, it could silt up. And so there's another danger there that that leakage can lead to silting, which means at that critical moment when you want to operate that valve, it doesn't move at all. So what does that mean for Declan? Well, he's looking at an accumulator-fed safety system, this blowout preventer that you see on the screen. And in an accumulator system, you have a amount of power stored inside the accumulator, relatively low flows, but at high pressures. But clearly, if you have any leakage coming out of the accumulator, then that power will leak away and won't be available at the moment that you need it, that critical moment when you want to control the flow to a cylinder to actuate the blowout preventer. So in this particular example here, the alternative or the sort of standard approach that Declan's seen in the past is to have 2 types of valves. You have a shut-off valve to hold the pressure inside the accumulator, So as we say there, prevents leakage from the accumulator when the cylinder operation isn't required. And then if you do want to operate the cylinders, you first turn the handle on the valve next to the accumulator to then power the valves next to them, and then you control the direction of which cylinder you want to actuate. So effectively, you have to have two different valves to do two different things: one to stop leakage, and the other one to control the direction. If you don't do that and you had spool valves, then clearly the power would leak away through the spool. If we were to look at a rotary shear valve, on the other hand, it has a different design, and so we don't have that same leak path. And if you look at the bottom there, we've got two red lines that's indicating the hydraulic flow, if you like, that's coming in the bottom of the valve. It's going through two seats, and the seats then go into the spool, the rotor, and the rotor then feeds the oil back through the appropriate hole and back out the bottom again. So the critical components in there are the seats and the rotors, and actually that's the component which gives a metal-to-metal contact, and you get zero leakage across that contact. And if you were to look at them and hold them together, the finish is like a mirror. They're specially hardened and lapped to achieve that. And the advantage of that particular design is that the higher the pressure, actually, the more those two surfaces get pushed together, and the smaller the leakage as a result. What does that look like in real life? So if we go back to the 3-position 4-port valve, and we were then to rotate it, first of all, we can see the spool on the inside, and we can see the relationship between the spool and the holes where the flow comes in and out. If we were to rotate the position one way, we can see we've joined P to A and B to T. And if we were then to move the handle the other way, you can see we've joined P to B and A to T. So actually the same functionality as we had before with the more linear operation of the spool valve, but with a rotary mechanism and a zero leak rotor. What does that mean in that particular circuit? It means that isolating valve that was there to stop the leakage from the accumulator is no longer required. So there's a saving there in terms of space, in terms of items on a bill of material, and in terms of cost for that circuit. And that's one of Declan's challenges. How can I just have that one valve rather than two to achieve that? So both zero leak and directional control. If we go back to the list of challenges that Declan put together, the first one was simplify and have one valve, not two. And so we can say, okay, we've looked at that. So the next one he's got is that he wants to minimize the piping in the circuit. And for that, he fears he might need a custom porting option. And why is that? It's because he traditionally might have only wanted a manifold mount or a line mount valve, but the way he wants to minimize the piping is he wants some of the ports to come in the bottom of the valve and some of the ports to come in the side of the valve, so that he can minimize the amount of pipes he need when installing the valve in the circuit. Now, traditionally, if you look at our data sheet for a shear valve, and I suspect that the same with many other brands out there, you can choose between having line mount, an O-ring mount, or an O-ring manifold mount, depending whether you want to put the bolts from the bottom or the top, or an ISO DO3 or CTOP 3 mount. And as I said, he's looking for something a little bit unique so that he can reduce the total cost of the installation. So what he's asked for effectively is he wants an 8-port valve. He doesn't want 4 ports on it. He wants all of them duplicated, both on the bottom and on the side. And that gives him the advantage that he could then choose which ones he uses, and quite simply then put a plug in the ones he's not using once he's installed it. So the third challenge Declan has is he wants high pressure capability. And he wants, which is not unusual, that's quite standard with shear valves, but the bit that's unusual is that he wants to be able to put multiple valves in series. So his choice, he wants a 350 bar, 5,000 PSI valve, but he also wants to be able to pressurize the tank line. He wants that so that on some of the designs, he can then put multiple valves in series, and so he can take the flow from the tank line and feed it into the pressure line of the next valve. So if we look at the design of the valve, you've got a choice really between, they all roughly got the same power rating, but you can choose whether you want higher flow and lower pressure, or higher pressure and lower flow. And so you can see here 3 different sizes of the valve. The first one, the item 1 there, you can see from sort of pinky purple color, high pressure, relatively low flow, so up to 15 liters, 4 gallons rating, but up to 10,000 psi or 700 bar. And at the other extreme, you can see slightly higher flow, so 10 gallons, 38 liters, but limited to 3,000 psi or 207 bar. And for his particular application, he wants something in the middle. So he wants a 5,000 psi, 350 bar rated valve, but up to 7 gallons or 26 liters. As I said, he's not just interested in that, he also wants the capability to be able to say, okay, I'm going to take the flow from one valve and then feed it into the next, so that I can use that power in multiple places. What does that mean? So if we were to look at the hydraulic circuit diagram and think about what the pressure might be possible on each of the ports, you can see there by those pressure gauges that the A, B and P ports all can have high pressure. What's unusual is that he wants that on the T port, and typically you'd only expect to see about sort of 17 bar rating on the T port, because you'd expect that to be going back to tank. So there's a couple of alternatives here. One is that you say, okay, well, I want to pressurize the T port, and you have to make the whole valve much stronger, much beefier, if you like, so that it doesn't blow up, which is one approach. And the other approach is you say, I'll put a 5th port in, and then you put a case drain in, if you like, from the top cap that feeds to the tank line separately. Both options are possible. He's chosen here that he's quite happy to have the 5th port, but that gives him the opportunity to feed that tank line onto the pressure line. We look at what that looks like. You can see there that the oil surrounding the top of the rotor can then come out of that port on the side. So that's what we call a pressurized tank port with vented cap. See there, the spool configuration can be whatever rotor configuration. Okay, so that brings us then to the 4th challenge that Declan has, and that is that safety is clearly a critical part of the industry they work in. It's one of their items on their mission statement, and he wants to make sure that it's tamper-proof, and so he wants to be able to lock it in position so it isn't accidentally knocked and operates a function without someone meaning to. And he's got a couple of options there. So for safety reasons, the valve must be tamper-proof. And you can go for an option which might be a button lock. We literally pull up a button and move the valve, or you actually put a key in and lock it so that no one can operate it at all. He's chosen that the key lock isn't perhaps suitable in this situation for a safety system, maybe because you could lose the key and then not operate the valve at all. But he wants to stop accidental operation, and so he's gone for the button lock, which means that once you've moved the handle, it then has a plunger which locks into place, and you have to positively remove the plunger in order to move the handle again. And you can see it illustrated on the screen there. So if we just recap on Declan's challenges, he's designing a new valve to control oil well safety equipment. He had 4 challenges that he feels he's got a solution to. What's he trying to achieve? He's trying to maintain a high level of safety and reliability at mining and oilfield services. He's had to be innovative. He wants to take cost out of his hydraulic circuit by simplifying the design, but he needs help with a custom valve. And by identifying these 4 challenges, he specified the ideal solution to control his oil well safety equipment. It's fair to say the valve didn't exist before, but Webtex guided him to a custom solution, and following the Make It Blue process has made that possible. Okay, so let's turn to his colleague, Steve, who's the service engineer. And he has a slightly different challenge. He's not designing anything new, but he's faced with the challenge that he has aging machinery. He has the challenge to keep those machines running longer, keep the costs under control, but you can't necessarily find the replacement parts. For whatever reason, the manufacturer of the original valve is no longer available. And so he's broken down his 4 challenges for the particular valve he needs to control the winches on these mobile drilling rigs into 4 areas. And the first one is he needs directional and pressure control, because the valve that he's got on there has a built-in relief valve. And he needs that replacement valve so that it combines both directional and pressure control. And so there's a whole load of different options that are typically available: 3-position, 2-position, 4-port, different sensor conditions. But what he really needs is that plus the pressure control on top. And why is that? That's because for a winch drive application, he has to make sure there's no leakage in there, so he needs a 0 leak valve. So if we look at the application here, if you've got a standard spool valve and no other sort of system involved, then you'd get some leakage. That leakage could mean that that winch will creep. That load get to the bottom. What's the alternative? We put a brake on there, and this winch has got a brake built in, and then he's got a control valve there in the top right, a power failure brake release valve, which clearly can't leak either, otherwise accidentally the brake could come off, which is a 0 leak valve. He operates that removes, that puts flow to the 2 cylinders, removes the brake, and allows the winch to operate. He also has a secondary function in there where he's got an override valve to, in case of power failure, that he can still get oil out of the circuit and get the winch to move. Okay, so we've seen a little bit about how the winch operates. For his particular system, he also needed a relief valve built in. And so here's an image, if you like, of how that might operate. He's got the pressure line coming in that is protected by that relief valve. And he's also got a vented tank connection in the top of there. There's the 5th port you can see in the center, but then he's also got the 3-position 4-port directional control valve that we've already seen. And that's then effectively the relief valve built onto the side of the directional control valve. So the next challenge that Steve's noticed is that he needs flow regulation. So the valve he's currently got isn't just binary, it's not just off or on. He needs that finer control for the operator. So he needs to be able to regulate the flow with the valve, and he doesn't want a separate flow regulation valve. He wants to be able to do that with the directional control valve. And what we call that in the valve design is interflow. So he wants there to be a small amount of flow that happens while the valve is moving from one position to the next. And you can see on the screen there an interflow valve design and a non-interflow valve design. What does that mean? I have a nifty little demonstration here that as the valve is moved from one position to the other, you can see the angle of rotation across the bottom there, and you can see the port pressure on the y-axis. So as that moves, you can see essentially nothing changes for the first few degrees. So up to sort of 20 degrees, nothing happens. But on the interflow version, you can see there's a gradual increase over sort of next 10 degrees of rotation of the pressure as the holes align on the rotor and the ports underneath. What does that mean in real life? Well, if we were to compare a spool valve, which is very much more the bang bang, a no interflow valve and an interflow valve, then we get a different sort of performance on the cylinders. The spool valve, simple, switch it on, opens very quickly. No interflow valve, it's a rotary motion on the valve, similar performance. On the interflow, we just move it sort of halfway, and you can see it's a bit more controlled, lower flow going through the valve, and therefore a slower opening on that cylinder. What does that mean for the operator? It means that they can have that fine touch control when they're operating the winch. So the next challenge that Steve's identified is that this valve isn't actually accessible to the operator. It's not actually on a control panel where someone could put their hand on a handle and operate it. What they need is a mechanical actuation because it's buried deep inside the machine, and it's going to have a linkage from that to a separate handle which is mounted further away. And so he needs a unique link for that. Needs it to be mechanically actuated, and he needs a certain detent or spring centering on the valve. So if it was spring centered, fairly obvious, it springs then back when you release it. And if it's detented, then different. When you release the handle, it will stay where it is. So he wants that functionality, but he wants it combined with the ability to be able to put a mechanical actuator on it rather than a handle on there. And so you can see there the example of the pin and the rod sticking out of the side of the top, so that the mechanical actuator can be attached rather than having a handle in there. And so that takes us through three of the challenges that Steve's got. The fourth one is that this machine, being a mobile machine, is sometimes inland and sometimes it's right next to the coast. And for the coastal ones, or if they're taken offshore onto a barge or something, then he needs it to be resistant to salt and humidity. So for those offshore or nearshore applications, he needs a marinized valve. And the choice there is in WebTech's ranges, we have the 180, which is made of aluminium, and the 280, which is made out of stainless steel. And so for some of his applications, he needs a stainless steel option. Essentially, the functions inside the valve are identical, but just the housing on the outside is then resistant to that salt spray. So that's it. So in a nutshell, Steve's challenge is to find a replacement winch valve for mobile drilling rigs. He needs to maintain a high level of safety and reliability at mining and oilfield services. He's had to be innovative in finding the MRO parts for that. He wants a like-for-like equivalent, but he also wants a few extra features in there. And he wants to be able to keep the existing machinery running for longer, while also maintaining his maintenance budget, because he doesn't want Lauren breathing down his neck saying, why have you spent so much on maintaining the machinery? So he's identified 4 challenges as well, and specified the ideal solution. And once again, that solution didn't necessarily exist beforehand, but WebTech has guided into a custom solution that we've manufactured with the help of the Make It Blue process. Where does that bring Lauren to? Well, Lauren's very happy that I've got a great team. Declan and Steve have done well in their jobs. Declan's proud he's designed a better and more cost-effective solution, and Steve's happy he's found a replacement valve to keep the winches running. So we just look at the options. Spend a lot of time on this, but you can see the various different options. It means when you add them up, there are well over 10,000 different versions of such a valve. Inevitably, they're not all engineered on day one, but the strength that WebTech has is it can engineer these solutions very quickly to build, as we've just seen, custom versions to solve particular challenges. So that brings us to the end of the presentation I've put together here. If you're interested in more information about the valves, then you can scan the QR code or go to our website. That'll take you straight to the product section for the zero leak valves. We have distributors worldwide who are knowledgeable about these products. I think some of them might even be on this call, and they'd be very happy to take your inquiry, or if you want to contact us directly, then there's our details on the screen there, and we can refer it to the right person. It's also an opportunity to take any questions if anybody's got anything they'd like to ask. Please feel free to put them in the chat or take yourself off mute to do that.
So Martin, there is one in the chat, and I'll just find it from Philip. So replacing the valve for MRO demand, and what would be the shortest lead time you can offer? Is his question.
Okay, all right. Thank you very much for the question. Okay, clearly that's a little bit, if I'm honest, it depends, but let's just talk about what's possible. So we have all of the designs in-house, we have all the manufacturing in-house and all the testing capability in-house. So that's always a good starting place. If someone comes to us and says, right, can I have a couple of pieces to get myself out of trouble for a particular MRO situation like the one we've just seen, then it's possible that we can get those through in a few weeks. I can't guarantee it until we know exactly what the configuration is. Our standard lead time is around 8 to 10 weeks on these products, but undoubtedly, if we can get good contact with the customer and say understand exactly what their specification is, then there are opportunities to squeeze these valves into production for emergency situations. The normal, as I say, sort of 8 to 10 weeks. If it's an emergency situation, we can configure and manufacture these products in weeks. It's not months to get people out of trouble. There's also a chance that if it's a more standard configuration, that we may have some items on stock in one of our divisions in the UK, Germany, or the US.
Okay, thanks,
does that answer your question, Philip? Hopefully.
So there's only yes, thank you. In the chat. If there's anything else, feel free, I say, to unmute yourself and ask it now. If not, you want to contact any of us afterwards, then feel free as well. Just give it a few seconds.
Oh, we've got a hand up there from Brian.
Yep. Brian, you should be able to unmute yourself. I will do it. If not, hold on.
Good day. Thanks for the yes. Thank you very much, James. I mean, it was very informative. I'm based in Mauritius. I would like to find out, do you design and build hydraulic power units?
No, that's something that we would work with our distributors for. So we don't design the whole power units, but we design some of the components, if you like, that would be used on them, whether that's from a measurement point of view or a control point of view. But yeah, then we would direct you to one of our distributors that you can find on our website in order to assist with the designing the whole power unit.
Thank you very much. One last question. How about training? I'm quite interested of what your training looks like. So do you do a training, customer training?
We don't deliver training ourselves. What we've done over the years is help collate and put together quite a lot of training material. So we have the book that I mentioned at the beginning of the presentation. If you go onto our website, there's quite a lot of resources broken down by chapters of that book, as well as videos, case studies, white papers, and the like that you'll find there. And you'll also find some links to some of the trade associations. So if you look in the US, we're members of the NFPA, in the UK of the British Fluid Power Association, and we work closely with a couple of different training centres. So in the UK, the National Fluid Power Centre, and if you were to look on their websites or email us and say where you're looking for some training and which area, we can point you to accredited training organisations, many of whom we've known for many years, and would may use some of our equipment or some of our resources that we've provided.
Thank you very much. I do appreciate this. Thank you very much, sir.
Yeah, not to mention, perhaps one thing to add on that, Sam, is that many of the distributors that we work with also have their own training resources in-house as well. So it's always worth asking local distributors.
Yeah, Brian, I'll reach out. Sorry, carry on, Brian.
Yeah, no, thank you very much. I was just, I think, about to ask you the same question. I was going to contact you via email. Thank you.
I'll reach out to you as well with some links and point you in some directions of areas that can help. Yeah, I'll do that this afternoon.
Thank you very much.
You're welcome.
Thank you very much. Do appreciate. Thank you.
And if there's nothing else, then we'll finish there. This, excuse me, the recording will be emailed out to you within the hour once I've processed and saved it. So you should be able to rewatch it or share it with any of your colleagues, and I'll put it up on our website as well. And as I said earlier, this is one of 4 we're going to do this year. So keep an eye out for emails, LinkedIn, the website for future webinars that we're going to hold later on in the year. And Martin, unless you've got anything else, we'll finish it there.
That's good. Thank you very much for coming, everybody. Thank you for your questions. And yeah, we'll see you next time.
Yeah, thank you, everyone.
There is another